And we have started. Go, Chris.
All right, welcome to an episode of All Things 3D. Today we are here. It is 7/17/2014. It's Thursday, and we have a special guest here tonight. Um, my name is Chris Kopak. I'm your co-host, and we have Mike Balzer.
Hi,
And
this is
today
Mike
we're
again.
and today we're interviewing Scott Pobihun, who is the
Good
CEO
morning.
of Hard Cotton. And welcome to the show.
Thank you.
And Scott here has a new SLA printer coming onto the market via Kickstarter, a Kickstarter project, and he's going to tell us a little bit about it. So welcome, Scott.
Yeah, thanks. Thanks very much.
So you're on.
So
So,
yeah, so tell us a little bit about where you live and what you do for a living, Scott.
Yeah, okay. Well, I'm in Canberra, Australia, so the capital of Australia, and yeah, I'm a government lawyer by trade. So during the day, I write legislation, and by night I make 3D printers for a hobby. So yeah, no, it's
Wow.
an interesting mix, I know, but I've got a computer engineering background as well. So
well,
hence
that would
hence the
explain it again. But it seems like
yeah.
we've had a lot of people who this is kind of like their hobby or nighttime job. So you're not the
Mm,
first, and probably won't be the last. Um,
doubt,
but
yes,
it
true.
but it's cool to see the diversity in the group of people that are doing other things besides just technology. So I think that's kind of neat.
I
So
think it
you're
helps too.
lawyer.
I think it. Sorry, yeah. I think it helps too. It sort of brings something different to the table, like some having something outside of technology, and you know, it, I think it allows you to sort of think outside of what some people would be sort of focused on at the time, and I think that's what's happened with us with with the Elemental 3D printer that we're trying to introduce.
Yeah, well, I think that's great. So, speaking of the name Hard Cotton, how did you come up with that? That seems a little obscure and different.
Yeah, yeah.
When I think of cotton in the United States, I think of the deep South, like Mississippi. So, I'm assuming that cotton can be made in Australia.
Well,
That,
this is true, yes, but we've had quite a bit of feedback about the name. A lot of people are intrigued, and a lot of people commended us on it. I won't take credit for that. My business partner Richard Spreckley came up with the name. We had quite a few on the table, but basically it's a hats off to the material that really started the first industrial revolution, or one of the industrial revolutions, whether it was the first or second, I'm not sure.
now, that's
And
a
the
good
fact that
point.
yeah. So really, it's about the fact that with these milling machines, putting all the cotton together, it really started mass manufacturing. So we're sort of trying to hats off to that, and follow that path really.
Yeah, that's the cotton gin. And actually, I've heard that numerous times in other technology podcasts and in writings where people bring that up. So kudos to you for the name.
Thank you.
Yeah.
Well, thank Richard.
Okay, so my next question is I'm going to get right into it. First of all, cool name for your printer as well, the Elemental. And so I, the other thing is this is a unique SLA printer, and I'd like you to tell us a little bit more about it. You probably got some secrets you want to hold to yourself, but I really would love to hear more about it.
Sure. Yeah. Yeah. Excuse me. As I said, I've got a cold, so if I have to clear my voice a bit, apologies. I do have some videos that I can show you on how it operates and whatnot. So again, forgive me, I am new to the Google Sphere, so I'm learning on the fly.
Okay.
I can demonstrate a few things to you, but I guess a bit of a background to it all. As I said, I've been um, playing with 3D printers for a while, and like most of us, we all sort of get in with the FDM uh, kind of 3D printer, and I one of the things about those machines, I just always found them quite difficult to use and whatnot. And I played with lasers at university through both my studies and also creating laser light shows for a mate of mine. So I had some sort of experience with controlling lasers as well, and understood, that's how stereolithography worked. And I thought, well, this technology seems to be a lot easier to use, simply because it's curing liquids and whatnot. So I was playing. I built my own SL printer. I've had about 30 versions of SL printers to come to the Elemental. Really enjoyed playing with those things, but with the kinds of SL printers that I'd made, I was sort of limited in how to use it. Obviously, with the classical system with the vat, the platform goes into the vat, and you have to have a whole vat full of, back then, very expensive materials. I was using, it's in front of me, isobonyl acrylate, which is quite expensive per litre, and then came about the upside down SL printers, and obviously they were great with reducing the cost of the materials, and things have sort of been coming together, I think, for SL, in that you've got the vendors of the much cheaper materials coming out, and therefore I thought, well, this is really showing that SL is going to open up a lot more than it was back then. But I tried to create an upside down printer, SL printer, and because I was using the isobonyl material, the isobonyl is very viscous. It's quite thick, and you can't obviously lift the platform off the bottom of the bed like your Formlabs machines and whatnot, because of the vacuum that you have to have at the start. And I felt, excuse me, well, this is quite difficult, and I was trying to find a way that you could have a variety of materials, and so the moving platform was the real issue. So I thought, well, how can we get a static platform, and then we can move the materials around to allow us to use lots of different materials, and obviously have support material underneath it, i.e. saline solutions, and then floating lighter materials on top of that. So that's how the pressure control system came about, really. Yeah, so in answer to your question about how that works, it's not directly controlled by a pump, it's controlled by valves. So that's why you've got these control chambers around the build area. I can show you if I can.
You want me to walk you through how to move that? Essentially,
I've got screen share on the left. Is that the easiest way to do it? Yeah.
Yep.
All right.
And then just
I'll
pick
do the
that
screen
window,
share.
and then you won't. I don't think you'll get the audio with it, so you'll have to do a voiceover over it if you had any. So just keep
I had it all on mute because I thought I'd go through. So some of the stuff that I've put together for this morning is some of the cut work from the Kickstarter video, and some of it's the stuff that that I've just videoed of the processes. So now, would you like to see some more of the machine first, or or some of the printing processes, or what would you like to see first?
Let's see the machine first, and then the printing process. How about one right after the other?
Okay, let me just, now, how's it saying? Select a window to show the video call. What do I do here? So, okay, yep, righto. Excuse me. Let me just get the machine up. Now, hopefully this, so I'll be able to open up a VLC, and can I share a VLC, can I?
You should be able to, yes.
Okay, let me just...
Yeah, just have a little window, and then go over to the screen share, and you'll get a choice of windows, and just select that window, and it should come up.
Okay, so if I go to screen share, right, okay, yes, okay, here we go.
Okay.
Start screen share.
Excellent.
Right.
We see
Okay.
it.
So you see it? Okay, good.
Yeah.
All right. So now one of the big things about the campaign, the Kickstarter campaign, is that we're going to be completely upfront here. The main reason why we're going to Kickstarter is because this machine needs to be mass manufactured. It needs to have plastic injection molding chassis and whatnot. So I'm being completely upfront, and I've said this before in interviews that have been picked up in Australia. It is CGI, so but it's based upon the materials that we've been quoted on in the manufacturing process and whatnot.
Yeah.
And the laser array is actually based upon the behavior as well. So, yeah.
Okay. Well, I've got some questions later on. So you do have a working model, correct?
Oh, absolutely, and it's
Okay.
to scale. It's to this scale. It's made of perspex and oh, what have I done here? Is that okay? Can you?
Yeah, we're good. So let's see.
So I
You want
can
to go on to
close
the
that?
next? Yep, and then just bring up your
Yep.
next window and move forward.
Yeah,
with
sure.
it.
Okay. All right. So what I might show you there now is the demonstration of the pressure. The pressure. So this is a shot of just the vat. So the vat is that green box is removable from the machine, and you access the vat through the top. So the top's a big lid.
Okay.
So I'll just play this now. Hopefully that works. Now, can you see this? Can you see the?
We can't.
Or do
You'll
I
have to go back.
Yeah,
You'll have to
beg
go
your
back
pardon?
to screen share.
Okay. So I'll screen share. Here we go. Yep.
There we
Okay.
go.
So you can see that. So this is a slowed down shot of what's in the Kickstarter video. When I start it, you'll notice from the start it's not level in the shot, and that wasn't entirely intentional, but actually it allows me to sort of talk more about one of the points that I've said in the media release, in that it is easy to use, and it is forgiving in that way. So basically, at the bottom of the vat, you'll have the build platform. So the build platform will be inside that. So this what you're seeing in front of you is the vat in the dual control chamber structure. So the two pieces on the outside are separate chambers, and on the inside is your build chamber. So that's where the laser draws each of the layers. So inside that area will be a static platform that is removable. So once the print's done, you can, and I'll demonstrate that to you through the video as well, how you print. But you can't see anything whilst it's printing. So like from the video cam, so like you can't see the fluid moving much from the build chambers. You can see obviously the fluid going up, but this front shot's a lot more much more explanatory. So this is, again, as I said, it's slowing down. It's a bit slow, just to give you more time to see how it moves.
Okay. So my questions on this
is it three separate? Oh, go ahead, Mike.
Yeah. Sorry. Yep.
Well, as you mentioned, there's no pumps, and so you're just controlling a valve which is modifying the pressure between the two, or I guess the two separate channels. Is that what I'm understanding?
Yeah. So there obviously will need to be a pump to set the process up. But in the printing process itself, it's very difficult to control it by a pump, because obviously the pumps need to wear up, and you don't have that accurate control. But with valves, what you're doing, let me share it again so you can see what's going on.
So first you establish the pressure through the pump process, and then once that's whatever sort of rate you have, then you can control it. Is that what I'm understanding?
Yeah, so basically, like, if I mean, I think we've all done this. You get a straw and you suck up some soft drink or whatever, and you put your finger on top of the straw, and the liquid stays inside the straw. So because there's the pressure, or you haven't you're controlling the pressure above the material in the vat. If there's no airflow from above, the material in the control chamber at that time won't move. So obviously, what you're trying to do is transfer the material from the control chamber. So that inside chamber that you can see that's full or fullish will move into the build chamber until a point of equilibrium.
And we see your mouse pointer, so you can use it kind of like a pointer to.
Oh, okay.
Yeah.
Yep. All right. Okay. So yeah, as I said, this is the build chamber. This yellow one. Now the whole chamber, the whole vat is a greeny yellow. That's the color of the prototype. The entire prototype vat is this greeny yellow thing, and what I have on the top, if you can see where my mouse is, are some arms, and you'll see that in a later video, and then the platforms at the bottom. So at this point, you've got this is the chamber that is initially full of material, and this chamber is effectively empty of material until like to this point here. So this is your entry point. So the material flows from this chamber through into the space that's got the access to the change in pressure. So this material here is going to go in here because this chamber is open. Okay, so it's just open up to the atmosphere. It won't flow into this chamber because this chamber has a valve in it as well. Okay. So if you open this valve, the material would move from this chamber into both chambers. Okay, so what you can do in the dual chamber situation is if you're building something, and it came about because I was experimenting heavily with the different kinds of materials, and a good example of a scenario where this might be useful is if you're building a cup that's sitting like properly, like with its base at the bottom. So if you are curing the material and the material is actually curing above the surface of the liquid for whatever reason, maybe you're overpowering the material and it's creating a wall, you won't have any material going into the center of the cup. Now, for a cup, obviously that's fine, but if you want to put something else in the middle of that cup, then you've got a problem because you can't cure that. Well, there's no material to cure in there. So that's one of the reasons why we're offering this format. The other advantage of having the dual chambers is that if you're only building a small object, you don't need to fill this entire vat with either the saline solution supporting the material or the entire vat full of resin. So I'll do it again, and I'll stop it before it closes. So you can see here at this point that's how much resin is in the build chamber. So you would have printed to this point. So does that make sense? Do you understand what I'm pointing at?
Mm-hmm.
Yeah. So again, as I said, the platform's static. At the start, this chamber's full of material, and this chamber, your build chamber, what you would do is you just make sure that the liquids, like the liquid, is just underneath the platform. So I found that the good thing about this is that it doesn't have to be like spot on, like at the surface of the build platform to get a print that worked. Obviously, you could have support structures to start the whole thing off. You could put some links onto it, and that's one of the good things about this is that it means that the build platform and the VAT doesn't have to be entirely level. The machine is going to have feet on it that will allow you to level the machine, so that should eliminate most of those problems. But it's still actually quite forgiving because the material, you can just build the support structure before you start the print. I've got some prints and I can show you how like the benefits to that.
Okay.
But one of the other things is that because you're surrounding the object that you're building with resin or with a saline solution or whatever, it allows you to excuse me. It allows you actually to use that material to hold up the object whilst you're printing. So one of the things that I printed, and I haven't got it today for you, but was a very, very, very thin cylinder, and I printed it, and then it worked, and then as soon as I pulled the material down, the whole thing collapsed. So that to me told me it was, well, okay, well this means that this material is holding this thing up until such time you take the resin away. Obviously, with that sort of process, you would obviously design some sort of structures to hold the whole thing together, like the cylinder, so it doesn't collapse at the end of the process. But I think you can understand that's one of the good things about having this whole object like surrounded by the liquid that it's working in. So we'll just play it again.
And so it's building on the concept of floating resin. For our listeners that don't understand the process, it's building on this process that kind of was pioneered by somebody we were talking about last night, and I'm trying to remember their name, Mike.
Yeah, I don't remember either, Chris.
Where they float, where you're essentially floating your SLA resin on top of a saline solution because it's lighter than the saline, correct?
Well, you can do it that way. I think you're talking about Pachy.
The Pachy, yeah, there you go.
Yeah. The Pachy uses my understanding is it's quite different to this in that it's a dripping system. So it feeds the material into the area.
Right. The process is different, but the concept of floating the resin on top, I think the Pachy was the first time I had seen it, or that concept I had seen. So, but the idea behind this is you're not filling your whole build chamber with resin, expensive resin. You're filling it with just enough resin for your print, but most of the material you're seeing in the pressure chambers is a saline solution.
That's one way of operating it. I've operated it both ways. I've actually filled the whole vat with the green green material that you'll see some of the objects printed that I'll show you. There's benefits to using both. Obviously, if you're supporting, like I've described it as support material, saline, you can float light material on it, but there's a very limited number of materials out there that can float on saline. I think that's a big area. I think that the technology, if people are picking up this kind of technology, then it will sort of open up vendors to develop lighter materials that are useful, for more economic printing. The one big thing about this method is that there's no interaction with the saline or with the resin, so that the materials don't go through any valve. now, the big advantage of that, obviously, is that that there's no way that the material can either clog up the valve or damage it. So it's a much I haven't had any problems with the valves, put it that way, because it's just pushing air around.
Okay.
Obviously, you could use inert gases or whatever instead of air, if like in the future, if people think that there's advantages to using different gases, then that's all good. So going back to the printer.
Yeah, we're going to have to move on to some of the other questions.
Okay, sure. Yeah. Would you like me to demonstrate the print process then?
Yes, please.
Okay. All right. Okay. Now again, this is time lapsed. Okay, let me just see if I can open this.
So while you're getting this up and running, one of the things that I noticed that was very striking about it, one, it had a very minimalist design, which I think is really good. The other is that most of the SLI printers that I have seen use a translucent amber viewing area, and you are using a light green. But if I remember reading about your documentation, you're still using a 405 nanometer laser. So
yeah, sure.
Is there a reason you've gone to this? Is it does it really even matter? Or we also found out last night, and I was aware there are certain materials that you can make your, what would you call it, the outer exterior that blocks UV. So is that the direction you've gone and just given it a light green tint?
Yeah, well, for one, the first product that I use, the isobornal, it doesn't react above about 410 nanometers. So with a lot of these materials, they're Blu-ray lasers. They're running at 405, but they're in your Blu-ray players and whatnot. It's actually my understanding is that it's actually the side banding at the other end of the spectrum that's actually curing it. It certainly is with the isobornal. I do know I've used Sub-G from Maker Juice and Sub-G Plus, and I understand that the Sub-G Plus goes, I don't know about I'm assuming it's the same, but the Sub-G Plus goes up to 420. So the green is about 500, well, starts at about 510 to about 550 or so. So it's still a fair way above the curing spec area, like exposure energy range. I have had no problems with the VAT in indirect sunlight. It doesn't have any problems there at all with that. So so I thought, well, this is fine. It looks good. We did want to distinguish ourselves from other manufacturers as well. So yeah, basically there doesn't seem to be any problem with green, and we thought, well, it looks really good with green as well. So it is important to us that we have a good looking machine as well, because I think it's one of the things that would open up the 3D printing products to the consumer part of the industry. So yeah.
No, that's a good point. But you mentioned that this is in the 500 nanometer. So are you using a laser in that respect, or are you still using a?
Sorry, I beg your pardon. No, I meant the plastic being in green. Controlled, like is a filter at that sort of level. Theoretically, a filter there, but most of these materials don't filter that much.
Okay, and if you remember, my question pretty much indicated that. So essentially, depending on the wavelength of the material, as long as you do not have something in the 405 or that spectrum, you're okay. So it doesn't matter really the color. Okay.
No, I certainly wouldn't recommend anybody printing in direct sunlight. Just because you're going to open up the vat and pull the object out, and I don't know how that would go. But I certainly don't have to work in the dark, and there's no problem with regular light from light bulbs and whatnot. Now, would you like now? Let me go for here. You are. There you are. Okay, let me show you the print process. Time-lapse video. Here we go. Start screen share. Right. So what you're seeing here is the print process, as I said. So I'll just let it play, and you can see. So this is creating a green heart. So this is a process where the entire vat was filled with sub G green. So it's just zipping around. You can see how there's little specks. Can you see? I'm not sure of the resolution that you're getting, but whoops.
Yeah.
Oh,
the little blue specks are the laser.
Yeah, that's right. Yeah. Let me play it again, and I'll stop it before it before it cuts out.
Yeah, that brings up something that I'd like to talk about. Is at least on your website, or it appeared to me, and you didn't have any high resolution images. The finish of the models seem to have a kind of a textured, mottled appearance to them.
Yep.
Was that just what you used for models, or is that part of the process? And will you be able to get a smooth finish, and you just didn't move in that direction, or is that still undergoing process?
There's a couple of points to that. What we've been doing, the first prints that very few people would have seen were purely saline supported prints. So this second set are what I'm describing as faster. You would have seen in our media release that the XY resolution is variable by software. So with these ones, I'm not running it at the full super high resolution printing process. I do have some objects here that I can show you that are a lot smoother.
Okay.
It's not a limitation of the hardware. It's the way I've run the software for a couple of reasons. I think one of the things is that so I'll just show you so you can see that. So you can see the liquids. So the liquid's going up, and you can see the little blotches where the heart's getting printed, and the Blu-ray lasers bouncing around. So again, this is in time lapse. And I can show you what happens at the end of the process as well. I can show you just taking the object out. Well, sorry, the vat emptying, so you can see that a little heart. Now I've raised the contrast a fair bit on this because it was quite dark in the video that I had.
Okay.
How am I going with my screen sharing? Am I right?
Yeah, you're doing good.
So there's the heart. That's how it's come out.
Why don't you go ahead and pause it to me, and then put your cursor on it. Notice the exterior texture there. Is that part of the model itself? I guess that's my concern.
Yep.
So is that the appearance of the model you're using, the software, and as you mentioned, you'll be able to show us something with a smoother finish?
Yeah, I can. I've got the heart here.
It kind of resembles the surface of a golf ball, and
well, it's it's probably a little bit hard to see on the screen, but I can show you the heart.
Okay.
Do you want me to show you the shot of the coming out so you can see what it looks like as it's come out? It's not very long. Where am I? Object out of it. Here we go. So this is all prototype, so it is quite rough, and you'll see some taps and whatnot that are not in the design for the final. Now I've got, here we go, share again. Okay, so this is demonstrating me lifting the platform out, and there's the heart. So it's a bit amateuristic, but had to like just as a proof of concept. That's how it works. So now am I back? So that's the little one there. Now you're probably not going to see the modelness, but basically, why that's happening is that a couple of reasons. One, because as I said, we're not when you're obviously drawing a line across the, say, from X1 to X2, and that's all the way across the entire spectrum of the laser's capacity to draw a straight line across the build. So maybe, say, for 12 bits, 4,096 points. To make it faster, you can actually just skip, 5-10 points.
Gotcha.
So, and this is what this drip feeding the information out to people a little bit, in that when you're prototyping objects, you might want to make sure that it is something that you want. It's something, and you don't want to wait around for a long time, because obviously, if you're building at very fine layer heights and high detail, then you're going to take a long time. But you can cut down on time by having it with that mottledness. So it is. That's one reason. The other reason is that with this prototyping stuff, I actually use quite a powerful laser. The prototypes we're looking at putting a 200 milliwatt laser in it.
Oh, okay.
And the reason why is because it'll allow you to use different materials. The material does, I think most of us understand that a lot of the Maker Juice stuff can shrink. So more power into it, more likely it's going to shrink. So the isobornal doesn't. The isobornal actually stays much more stable and doesn't shrink. It just sits there. So it is dependent upon the materials, but it's fine tuning. So that's our process with getting the information out there. We want to show you first the saline objects, and also the quick prints. And by quick, one of your questions that you gave me was the software that we use. So basically, one of my favorite slicing software is Cura. Cura is obviously very, very fast to slice, so I play with Cura. And
I use it on two different printers. So I have an Ultimaker 2, and then I have a Castle Clear, and I use it for both of those. So I agree with you. Cura is a good application. So you can actually use Cura with your printer. So that's a good thing to hear.
Yeah, so basically I thought, well, with the tool chain, I want to make it as close to FDM slicing, because it's very fast, and it's neat and everything. I can get good quality objects out there. Now this is very small. I'm not sure whether you're going to be able to see this or not.
Yeah, the quality of the video leads a little bit up in there.
Yeah, beg your pardon. So basically that, I mean, you're going to have to believe me on this, but this one was built with saline, so it does again depend upon on the material. But this is Maker Juice G, grey white or whatever Josh calls it. It didn't react the same way. It's very hard to see any layering in either the X, Y, or Z layering. So there is that too. So
could I suggest that you might make a compilation of images that people can download at a fairly high resolution for inspection? Obviously you've got only a few images up on your website, and I notice a consistent modeling across all of them. So So that's the reason to concern the question. So I think more images showing some of the smoother models might help ease some of the concerns that people may have in moving forward with your product.
Absolutely. I've got some models here that I can show you, and can show you some of the issues that we faced. I've brought some fail prints as well if you want to see what the risks are with pressure controls and how we can overcome that.
Okay, well, we're getting pretty close to answering all of my questions. We talked about no moving parts. How are you controlling the lasers then? I mean, I'm assuming
Well,
they.
yeah. So there's no moving parts in the build area.
Okay.
So it's a laser galvo system
Okay.
with valves controlling the direct area, and then there is a wet pump that provides more cells. There's cells on the inside of the chassis that assist with the sucking out of the material, so you can actually see the object as I demonstrated in that third print video.
Okay.
So that allows you to sort of move things around a bit more. So there are moving parts, but to me, the most important thing for the user was that technical mechanical part of 3D printing is gone. It also
No,
allows
I
us to.
really agree with that. That's extremely important, and so okay. I just wanted to differentiate that. Yes, you still have galvanometers in there, and then you
Yeah.
have a pump initially to generate the pressure for your chambers. But other than that, the rest of the process is just controlled through some valves.
Yeah, that's right. And the other advantage to this, obviously, is that from a manufacturing process, you are going to have a module where you have all your electronics that's inserted in the back of the chassis. They then are plugged into the valves and the pump, and then that's pretty much it. So from a manufacturing process, it's good as well. If you I'm not sure whether the Ultimaker 2 is whether you built that, but I certainly have built FDM printers and they took forever to build. So yeah, getting that manufacturing process down by having a format that allows you, quick processing. That was the other main reason why we went down this path as well.
Well, and let's see, I just have one more question, but it's a good segue, and I'll just jump back to it. That would probably explain why you have this for a very reasonable price of what, if I understand correctly, Australian dollars of 1,000, which
Yeah.
at the conversion rate that I sent the questions out, that was a $940 US. So that's under 1,000, and that for the build size you're talking about, that's very respectable. So is that just a Kickstarter special price, or is that the plan for once you get past the Kickstarter?
Well, it is a Kickstarter bonus.
Okay.
Obviously, we want to get these machines out there, but won't go too much into that and into the pricing yet. It's obviously too early. We've obviously got some things that we still have to deal with, but certainly the advantage of this is that we don't have the labour costs in assembling these things, so that makes it a lot easier. And the components, generally, they're more accessible. The controlling hardware, much simpler as well. So yeah, all up, it allows us to actually get a machine out there for a lot less money than others. Yeah.
Okay. Well, yeah. So if I understand correctly, for $1,000 Australian dollars, you can get one of these as an early bird, or will that be the price throughout the Kickstarter campaign?
It'll probably be the early bird, but it won't be like 5 or 6 machines at that early bird price, and it won't be a very deep price range either. So yeah, we are, as I said, we want to be open and honest about this, and our philosophy is that this is going to be, it's not going to be cheap to set up, so we're not going to, seek a small amount of money either. So sort of reduce the risk to yourself. If you're interested in getting one of these things, then if we don't reach our goal, then you haven't lost anything either. So making it clear that we're looking at a reasonable amount of money. Because the tooling of these things is the expensive part, really. We've got the quotes, obviously, but we've got to get that done, and if we can get that done, then we're set. So
Yeah,
Great.
that's really good to hear. So let's go back one more question on the technical side. You mentioned this will be controlled through Bluetooth. Will you also have the ability to use SD cards, which would be something different in this market? So you're nodding your head yes. So
Yeah,
uh,
yeah. Well, I haven't really spoken about the SD. The big thing with Bluetooth over Wi-Fi, obviously, is the cost of the hardware. I don't know whether you realise, but yeah, the Wi-Fi components are very expensive compared to Bluetooth. And one of the good things about Bluetooth, and because this thing is quiet, and when it's full of full of resin, you won't see much happening. So what I'd like to do, this hasn't been developed yet, like this side of the software, is to get a notification, through a Bluetooth device. It can be tethered to, and this is the way the prototype's working, it's tethered to a PC. With the SD card, the way I developed the software is that I ran the G code. I wrote the G code myself, so I wrote all the firmware myself, and then to get the G code working properly, I first developed it in the PC and ran the printer as a dumb terminal, basically. So basically, just sending the data raw. This is what I was going to elaborate on a bit more with you guys, and I haven't really said this before, is that the software model for the system will be that we have the embedded G-code method. So, and then we'll have, and this will sit on the SD card, the space where if you want to do what I've done and develop your own G-code or your own SVG format or whatever way to display the pattern onto the machine, prototype it on your PC until you get it right. Put it onto the machine, and then off you go, and then the machine will run faster. I've found that transferring the G code control to the machine much faster, and obviously if you have the G code file that you're printing from on the SD card, it's fast. Well, in my experience in the past with FDM printers, it's certainly faster as well. So yeah, definitely. Yeah, the budget's there for the SD. That's definitely going to stay in there for sure.
yeah, well, that's in my opinion, an exceptional point. And one of the problems with a lot of the printers that don't have that feature is speed. Going through the umbilical cord is not conducive a lot of times.
Yeah.
One is because a lot of them are using Arduinos at a baud rate versus a USB rate. So SD card is the way to go. And plus, it allows you to use an autonomous printer, which I think is extremely important as well. I have a Form 1, and you still have to channel it through USB, but it does appear to be using USB transfer speeds, and then it will push the whole file over to it and then store it, and then you can disconnect your printer. But I like the idea of putting it on a card, throwing in it, because then you can go back to it and select. I noticed there wasn't any moving buttons, but I'm assuming you could go back and select different models without ever having to bring a PC back into the game, and I think that's extremely important.
Yeah, and I think this three ways of operating the machine would really open up how the machines operate. Like, it'll open up the system to enthusiasts. The people that are hackers would, I'm sure would love to have a go at, doing things differently. There's obviously different flavors of G code around, with the firmware of, Sprinter and Marlin and all those. They behave differently. So, it helps us obviously too, because if the performance is there, by all means, someone could have a go at developing a better way of printing, a more reliable way of printing, or whatever. So yeah, no, I think it's a good model that we can easily do.
Well, yeah, it's really good to hear. So my last question, and then I'll turn it over to Chris, is, okay, so we kind of know the price. We know a lot about the machine now that we didn't know. I guess the most important question is, when can I get my hands on one?
It's a good-looking machine, isn't it? A lot of people have been
Yeah,
quite
I agree.
enthused by the appearance, and that's been an important thing for us as well. So the next step for us, obviously, what with the prints, what my philosophy's been with that is that. And you'll see this in the Kickstarter video, it needs to be simple and easy to use. So once I get to a point where I'm easily printing things without failure, I get the materials up there, get the objects up there at that grade. So we're getting the good quality prints out there, but we've got to tune the software a little bit more to get it out there, and that's when we'll be publishing those objects. I'll show you some things soon. So from then, most of the other things are sorted out in terms of planning for Kickstarter. So we've gotten the word out. Obviously, the media's been attracted to us, so that's fantastic. The strategy has been to get the word out to make people aware of what we're doing, so we can get to Kickstarter soon. So we've got to have to keep that momentum up. So we do want to launch on Kickstarter within the next month or two.
Okay.
Hopefully within the month, and we'll do the classical 1 month Kickstarter scheme, and then touch wood. We want to get all the tooling and whatnot all sorted by the end of the year, and then hopefully we'll get machines out there, within 6 months, hopefully. But it's I don't want to mislead people. There's paths, and we have to get them the tooling done. So that's probably the one thing. But that's the only limiting thing from my perspective is how long it's going to get that all sorted, and then we'll get machines out there.
Okay, well, as I mentioned, I want to be on the insider list because normally I find out about these things,
All too late.
all too late, and I go out to the Kickstarter and they're all gone, and that always sucks. So make sure I get on the insider list on this one.
Well, the reason why we're going for a large volume, a large number of dollars in Kickstarter is so we get this done properly. So that will reduce your chances of missing out, because we do want to get quite a few machines out there.
Well, that's good to hear. So, Chris, you got any questions before we close things off?
No, I just wanted to thank Scott for being on our show, and hope our listeners benefited from this as much as I did. I think it's a real interesting concept. I think this pressure chamber thing, I think it's just going to, I think it's a really interesting concept, and I can't wait to watch this project evolve.
All right. No, thanks very much. Yeah,
I totally agree. So, Scott, you got the last word.
Oh, look, no, thanks for your time, really. It's been good. Getting the word out there is important to us, and it's been enjoyable. Thanks very much, and thanks for getting up so early, and I'll go to bed now.
All right. Well, we look forward to seeing you on Kickstarter.
Okay.
And
thanks, guys.
again, this is All Things 3D, and this is our interview with Scott from Hardcotton and his new Elemental. So again, thank you for tuning in, and this is a wrap.